Hi, and welcome to the Ticket Out the Door videos for Math 126. These will be the Ticket Out the Doors between Exam 1 prior to Exam 2. And there's 5 days worth, or 5 class days worth of Ticket Out the Doors. I'm probably going to break this into 2 videos. The first day of Ticket Out the Door videos that we had, or the Ticket Out the Door problems, was February 26th. The first one was solving a system of 3 equations. So we wanted to solve, and we have 2x plus 3z is equal to negative 11. We have x minus y plus z is negative 6, and x plus 2y minus 2z is equal to 9. So with these videos, I'm going to try to go through a little bit quickly. Again, it's more so that if you had trouble with the problems, then hopefully you're able to kind of see how they work out and figure them out from that point. So with this, the first thing we want to do is turn it into an augmented matrix. And with these systems, like I told you guys in class, if you're in my online course, the suggestion I give is to get zeros in the bottom left-hand corner and then get out of the matrix. Do back substitution. So with this one, the other thing that I want is I want a 1, ideally, in the upper left corner. And I'm allowed to switch rows. My 3 elementary row operations are what? I can switch rows, I can add the multiple of one row to another, and I can multiply a row by a non-zero constant. So I'm going to switch these two when I put it into the matrix. So this is going to be what? 1, 2, negative 2, 9. Second row is 1, negative 1, 1, negative 6. And the bottom row is now going to be 2. I have to have a placeholder, so 0, 3, negative 11. Just check the video. Yep, okay, we're good. Want to make sure you guys get all this. So I want to put a 0 in this location here. So I'm going to do what? I'm going to do row 1 times negative 1 plus row 2 gives me a new row 2. So leave row 1 alone. 1, 2, negative 2, 9. And let me grab a different color pen here. So I'm going to multiply the first row by negative 1 and add it to the second. So negative 1 times 1 is negative 1 plus 1 is 0. Negative 2 minus 2, negative 3. Negative 1 times negative 2, positive 2, plus 1, 3. Negative 9 minus 6, negative 15. And then for the last row, I want a 0 where the 2 is at. So that's going to be row 1 times negative 2 plus row 3 gives me a new row 3. So if I multiply this by negative 2, negative 2 times 1 is negative 2 plus 2 is 0. Negative 4 plus 0 is negative 4. Negative 2 times negative 2 is positive 4 plus 3 is 7. And negative 18 minus 11, negative 29. And again, be careful. Again, I'm going through kind of quickly. Hopefully I don't make a mistake. But as you're doing these on the test, make sure you're taking your time. Make sure that you're adding everything correctly. Now, I want a 0 here ideally, but with the negative 3 and the negative 4, it's a little bit difficult. But if we look at this row here, I have what? I have all multiples of 3. So I can actually divide this whole row by 3. And so I get what? I get 0, I get negative 1, I get 1, and I get negative 5. So now it becomes easier to get a 0 down here because I can do what? Row 2 times times negative 4 plus row 3 gives me a new row 3. And this is going to be our methodology. We're going to use row 1 to get a 0 in row 2. We're going to use row 1 to get a 0 in row 3, and then we'll use row 2 to get a 0 in row 3. Then we can get out of the matrix. So if I do this row 1 and 2 stay the same. 1, 2, negative 2, 9. 0, negative 1, 1, negative 5. And if you divided this row by negative 3 to get a positive 1 there, that's fine. I just left it as a negative 1. So now I'm multiplying everything here by negative 4. So negative 4 times 0 is 0, plus 0 is 0. Once you have a 0, you better not change it back, otherwise you've done something mathematically wrong. Negative 4 times negative 1 is positive 4, minus 4 is 0. Negative 4 times 1, negative 4 plus 7 is 3. And negative 4 times negative 5 is positive 20, minus 20 is negative 9. So now that I have this, I'm going to erase this problem. I'll erase this guy here. So now that I have this, this bottom row tells me what? This tells me 3z is equal to negative 9. That's what this matrix notation does. Each column is x, y, z, with the last column is my constants. So 3z is equal to negative 9. So divide everything by 3, I get z is negative 3. Now, if I use the second row I have here, this gives me what is an equation? Negative y plus z is negative 5. So negative y, z is negative 3. So negative y minus 3 is negative 5. A lot of negatives here, so be careful. So add 3 to both sides. I get negative y is negative 2. Divide everything by negative 1. Y is equal to 2. And then last but not least, the first row, x plus 2y, well, y is equal to 2, minus 2z, so minus 2 times negative 3 is equal to positive 9. So x plus 4 plus 6 is 9, x plus 10 is 9, so x is equal to negative 1. So your answer should be x is negative 1, y is positive 2, z is negative 3. So that's question number 1. Again, I'm going fast through these. I want to make sure I get them all on video for you. If you need to stop or rewind or pause, then please do. Again, we're 226 for this. Question number 2 is a quadratic. We want to solve 2x squared plus 4x minus 2 is 0. So this one I cannot factor, so I'm going to need to use quadratic formula. So I have what? My a is 2, my b is 4, c is negative 2. So quadratic formula is negative b, so negative 4, plus or minus square root of b squared minus 4 times a times c all over 2 times a. So this is the equation you should have. Now it's a simplification. So negative 4 plus or minus square root 16. Negative 4 times 2 is negative 8 times negative 2 is plus 16. All over 2 times 2 is 4. So negative 4 plus or minus square root 16 plus 16 is 32. All over 4. Now be careful here. Most of you are pretty good at getting to this point, and then the cancellation becomes an issue. We cannot cancel this negative 4 with this 4. Remember what I keep telling you guys, everything or nothing. So if I can't cancel a 4 out of everywhere, I can't do it. I also can't cancel a 4 with the square root of 32. That's underneath the square root. This one is not. But what I can do is, by my square root rules, 32 is like 16 times 2. So this is negative 4. Square root of 16 is 4, so I can bring that out. So I get negative 4 plus or minus 4 root 2 over 4. And now, yes, I can cancel out a 4 everywhere to get ones, so I get negative 1 plus or minus the square root of 2. And that's your answer for number 2. Number 3. You want to rationalize the denominator. So one of your concept questions, denominator, is how do you rationalize the denominator? So if you see a problem like this, the thing that should come into your mind is, oh, I need to multiply by the conjugate. So in this case, what we're trying to rationalize is 6 over 4 plus root 2. So the conjugate is what? The conjugate is 4 minus square root of 2. So it's the same pieces we have here, just change the sign. So when I do this on the top, I have 6 times 4 minus root 2. I'm not going to distribute it, just leave it until the end in case something cancels out. And then when we FOIL this, 4 times 4 is 16. 4 times negative root 2 is negative 4 root 2, cancels out with the positive 4 root 2. That's why we do this. And then positive times negative is negative. Square root of 2 times square root of 2 is square root of 4, which is just 2. So we get 6 times 4 minus root 2 all over 16 minus 2 is 14. So all I can cancel here, I can divide this by 2, it gives me 3. Divide that by 2 gives me 7. So my final answer is 3 times 4 minus root 2 all over 7. So it doesn't look pretty, but that happens. Sometimes, actually a lot of times in real life, we're not going to get pretty answers for the numbers. So that was 226. Check my time here, 12 minutes, okay. So the next date, ticket out the doors, is March 2nd. 3-2, the first one is our domain problem. We want to state the domain in interval notation. We have square root of 1 minus x over x squared minus 2x minus 8. Again, another concept question for the exam. When you're trying to figure out how to figure out domains, what are our concerns? Is there an even radical? Is there a denominator? And in this case, we have both. So the first thing we need to do for the numerator is, and this is another concept question, if I have a radical, even radical, how do I find this domain? I set the radicand, 1 minus x, greater than or equal to 0. So if I move the x over, I get 1 is greater than or equal to x. So if I rewrite it how I'm used to seeing, x, the inequality is pointing towards the x, so I need to turn it around, is less than or equal to 1. For the denominator, this cannot be 0. So if I factor this and use zero property rule and say, okay, this can't be 0, this factors into what? X minus 4, x plus 2. And I know some of you are still struggling with factoring. Either practice prior to the exam, or if you do factor it, FOIL this. And if you FOIL it and it doesn't give you what you started with, it's not the correct factorization. So, set each of these equal to not 0, so x minus 4 cannot be 0. X plus 2 cannot be 0. So x cannot be 4, x cannot be negative 2. So I have all these domains now. For the numerator, x is less than or equal to 1. For the denominator, for denominator, x can't be 4, x cannot be negative 2. So if I draw these on a number line, for x is less than or equal to 1, it's a closed circle headed towards negative infinity. For can't be 4 and can't be negative 2, well, those are going to be open circles, but everything else I can have. So I get this picture here. So then where's my overlap? That's what I'm looking for, the intersection. Well, the intersection starts way down here at negative infinity. It goes until I hit -2, but I have to jump -2 because of this open circle. So that's my parenthesis union parenthesis. And then it goes to where? It goes up to 1, but because 1 is included in both of these, that gets a bracket. We know infinity always gets a parenthesis, so that would be your answer for number 1. For number 2, it's our quotient inequality, nonlinear inequality. So whether it's quotient or whether it's a product, it's essentially the same idea. We have to make sure the one side is 0, then we need to factor if we need to, set those factors equal to 0, build ourselves a table or the number line. So for this one, we want to solve for x. We have x minus 3 over x plus 2 is greater than or equal to 0. So this problem was kind of nice for us. It was already 0 on one side. It was already one term on the left side. It was already factored as far as it could go. So I'm going to set both of these, x minus 3 equal to 0, x plus 2 equal to 0. So x is 3, x is minus 2. So if I draw this number line, these are my breakpoints, so -2 and 3. And again, you can do this the way that's comfortable for you. If it's a table, do a table. I know some people do like blocks, like this is my interval block, what's my test number in here, that's fine. Whatever way works for you all the time, please do that. So, this is negative infinity, positive infinity, pick some test points in here. So let's go with -5, 0, and +5. And you can pick anything, -10, +10, just as long as they fall in those intervals. Now I'm using this guy here, x minus 3 over x plus 2. So if I plug in -5, I get -5 minus 3 over -5 plus 2. So that's a negative number over a negative number. Negative divided by negative is positive. And if I've done this right, if I've set up the table correctly, these intervals should alternate, positive, negative, or it could start with negative and go to positive, but it's going to alternate. So let's see, if I plug in 0, I get 0 minus 3 over 0 plus 2, that's a negative number over a positive. Negative divided by positive is a negative number. And plug in 5 minus 3 over 5 plus 2, that's positive over positive, which is a positive number. Now, please pay attention to this next step, because the issue I always get from students is, well, do I just take the plus, or do I take the minus? How do I know which one I should use? It depends entirely on our inequality to start. I want this ratio, or this product, if it ends up being a product, but I want this ratio to be greater than or equal to 0. Greater than or equal to 0 is a positive number. Therefore, I want the positive intervals from this table that I just created, or the number line. Now, the next thing to be careful of is don't use your test points. Use the actual values of the interval. So for this interval is what? It's negative infinity to -2. And this interval is what? 3 to infinity. Now, the last piece is I need to test these points. Test -2. Does it make the inequality true or false or undefined? Test +3. Does it make it true or false or undefined? So I know if it gets a parenthesis or bracket. If I plug in -2, what happens? The denominator is -2 plus 2 is 0. I get a 0 in the denominator. I can't have that, so it gets a parenthesis. What about the 3? Well, if I plug in 3, I get a 0 in the numerator, which is fine. But 0 is greater than or equal to 0. That's true. So in this case, the 3 is a suitable answer, so therefore a bracket. So that is going to be your answer for number 2. Number 3 is one of our mixture problems. says the following: how much 40% acid solution should be mixed with 10 gallons of 60% solution to yield a 55% acid solution. So, in the lecture videos, I showed you guys the table that we can use for mixture problems, either solutions or interest, mixture of money essentially. One day in office hours, one of the students and I, we were working through these, and I kind of put some boxes up, and like, okay, here's this, here's that, mixing to get this, and it clicked with him. So I'm going to show you guys that on this video as well. Maybe it'll click with you, make these problems a little easier to understand. So let's think about what is happening here. With any of these mixture problems, I have essentially two jars or two interest or something like that. This one is going to get poured into here with that one to give me my final solution. So this is my ingredient number 1. This is ingredient number 2. This is the total that I end up with. Now let's think about what this problem is saying. How much 40% solution should be mixed with 10 gallons of 60% to yield, or to end up with, or to total 55% acid solution? So I'm taking this 40%, I'm taking the 60%, I'm dumping them in to end up with a 55. So how does that look in this picture? Well, how much 40%? We don't know. Let's call that X. And it tells us that it's 40%. The other batch that I'm dumping in is 10 gallons worth of a solution that's 60%. And when I put these all together, how much do I end up with? Well, I end up with X plus 10. And what's the percent? Well, it tells me in the problem, I want a 55% acid solution. So now with these boxes, that kind of gives us the different rows of the table. And so now we don't have to do much thinking on that either. We kind of look at the boxes to give us some help. So we have what? Amount, percent, and for these solutions we call it pure, you can call it whatever. So ingredient 1 is this. It's X amount of 40%. So X of 0.4. And remember, with this table, we add down, we multiply across. So if I multiply this across, I get 0.4x. And that's getting mixed with this, 10 times 60%. So 10 times 0.6, multiply across, 10 times 0.6 is 6. And I end up with X plus 10 amount of 55%, so 0.55. So this one is 0.55 times X plus 10. So because I only have one variable, I only need one equation, which is always going to be the right equation. If I need two, I use the left and right. But if I only need one, I always use the right equation. So I'm going to erase my picture here. Hopefully you have it, or if you need it, you can go back. So my equation is what? 0.4x plus 6 equals 0.55 times x plus 10. So now, if you have a decimal problem, try to get rid of the decimals before you start working it. That way you're just dealing with whole numbers and you're not having to deal with decimals throughout. So if I want to get rid of the decimals, how many decimal places do I need to move it? Well, I only need to move it one here, none here, but I have to move it 2 places on the 55. So I have to do what? To move it 2 places, I would multiply everything by 100. So I multiply this by 100, multiply that by 100, multiply that by 100. So if I move it 2 places, this becomes 40x. plus 6 times 100 is 600 equals 100 times 0.55 is 55, and x plus 10. And I'm only multiplying it by the number in front because what? This is a product. So it's 100 times 0.55 times x plus 10. I only multiply it one time there. So now, go ahead and distribute and solve from here. Not dealing with decimals. So I get what? 40x plus 600 is 55x plus 550. So if I move the 40x here, I subtract 40x from both sides. If I move the 550, I subtract 550 from both sides. So I end up with what? 15x on the right side. 60 minus 550 leaves me with 50. So then go ahead and divide by 15. So we get x is equal to 50 over 15, which if I divide both of these by 5, divided by 5, divided by 5, I end up with 10/3. So your answer would be 10/3 gallons in order to yield that 55% acid solution. So that's it. That is number 3 for 3-2. And I see we're about 23 minutes here, so I'm going to stop here. We'll start up the second video with our next date for Ticket Out the Door. So we'll see you in that video.